In Bash, an associative array is very much like a normal array that we would use. The main difference between an associative array and a standard array is that a standard array uses an index number to identify each element or entry in the array. An associative array instead associates a key value, which is a string of text with each element in the array. So instead of our indexes being numbers, they're strings of text. This allows us to use anything whatsoever as an index, so we can actually make our keys into the array intelligent data. We could use, for example, a key named red to find the element of an animal's array for an animal that is red. The data contained within might be information about the animal itself, other than the color of it, because we've used the color as the key. We might use an interface name as a key to identify elements of an array, where the elements of the array contain interface information, and each element has data for a specific interface. So if we know the name, we can pull out the data for that interface. This does have one downside in that the indexes are not automatic. You must always specify a name for them. And of course, they're not stored in any particular order, unlike the indexed arrays that use numbers and are always stored in the index array order. The indexes themselves, the keys, in a standard numbered array are simply the numbers 0 up to one number less than the number of elements in the array. On the other hand, to retrieve the keys from an associative array, we have a different syntax. The other thing we have to do different with an associative array is we have to tell Bash when the array we're going to create is an associative array instead of standard. We do this with the declare command. When we say declare dash capital A and give a name of a variable, we are creating that variable as an empty array, specifically of type associative array. You may see this called a hash various places in documentation and online. The array is created as empty. We can put data into it by assigning data to a specific sub-value. Foo index some string of text equals something to put in there. We'll create an entry in that associative array. The index or key for it is the string red, and the data contained is some value in this case. So if I wanted to retrieve it, I would have to ask for the variable foo with index red. And since I'm using the index syntax, the whole thing, of course, must be inside curly braces. And you can see we're already running into a trouble with too many quotes of various kinds. The good news is you don't actually have to put the quotes on the index because it has to be a string. And it will retrieve that value. Just be careful because it can be a little hard to read when you're writing a script, especially if the names of the values and the indexes are long. Of course, the index value sometimes is literal text like this. Other times, it's actually the data contained in a variable. For example, I might have a variable called color, and it might have the word red in it. And I might be looking up the element of my array, by using the value of the color variable as the name of my key or index into the foo array to retrieve my data. So you can build this out in any way you like, and it makes it quite interesting. You can add as many elements to the array as you like by simply creating new values to put into new index strings. You must always specify the index string when adding a value, unlike a numbered array where we can simply use the addition operator to add things to the array. Because when you add things to an array, you need to supply the key. There are other hash syntaxes you can use to get more sophisticated with this. You can also create a set of values for an array to assign, similarly to what we did with numbered arrays. But if we do, we of course have to specify the keys. I could set my foo array equal to some contents inside parentheses. The difference is, if this was a standard array, I could go ahead and put my multiple values as strings. They'll be automatically indexed as index 0, 1, 2. But if I am doing an associative array, I also need the key values or index values. So I need to put those in. So I might create an index called red, and in there put cardinal. I might create an index called green and put frog in there. I might create an index called blue, and in there put whatever data is appropriate for blue. And I can build this list as long as I like, and it will assign these values into my array. To see everything in the array, instead of specific items like we did already, we use the special index @ symbol, and that will retrieve all elements of the array. Now, with a numbered array, they'll be in the numeric order of the indexes. With an associative array, the order is random. If I change the content of the array, the order they're stored in may also be seen to change. So if you wish to extract them in a particular order, you need to specify the keys. If you don't know what keys are going to be in your array because it was built dynamically, you can retrieve those by putting an exclamation mark in front of the variable name when retrieving your elements. And instead of retrieving the values stored in each element, it will instead retrieve the keys for each element, which you can then use to do whatever else you wish to do. The keys, again, will appear to be stored in what looks like a random order. You can't count on the order. We can also ask for how many things are in our array, just like we could with a numbered array, again by using the @ symbol as the special index to say, give me all array elements. Associative arrays are typically only used to build linked lists of data, where you have one list of information that you use as keys, and another list of information associated with that that you store according to the key values, so that you can retrieve it by the key values. This is a very useful technique in some circumstances.